Hello, welcome to my channel. Today we'll be talking about number line jumps. Number line jumps is a HackerRank algorithms, but for beginners basically. So if you are struggling with algorithm, the logic behind how you think like algorithm, web developer or a software engineer, so you are in the right place because I'll be showing you exactly the easiest way to go about this challenge, and also I will give you a step-by-step guide so that it will help you on how to be solving your algorithms. So let's just jump into it. You are choreographing a cycle show with various animals. For one act, you are given two kangaroos on a number line ready to jump in the positive direction towards positive infinity, like continue, not negative now, increasing positively, like 2, 3, 4, 5, 6, and so on. So the first kangaroo starts at location x1 and moves at a rate of v1 meters per jump. The second kangaroo starts at location x2 and moves at a rate of v2 meters per jump. So you have to figure out a way to get both kangaroos at the same location at the same time as part of the show. If it's possible, return yes, otherwise return no. Example. Example, x1 equal to 2, v1 equal to 1, x2 equal to 1, and v2 equal to 2. After one jump, they are both at x equal to 3. So let's look at it. x1 plus v1 is 2 plus 1. You can see 2 plus 1 is 3. Then you can see x2 plus v2 is also 3. So return yes, because after one jump, just a jump, they are already at the same location. So function description. Complete the function kangaroo in the editor below. Kangaroo has the following parameters. Integer. The parameters are integers. x1 integer and the v1 is also integer. The starting position and jump distance from kangaroo 1. Then the second kangaroo now, that the second starting position, which is x2, is an integer, v2 is also an integer, so it's the starting position and jump distance for kangaroo 2. So if it's possible that they can meet at the same location, then you return yes. If not, return no. So the logic here, let's look at this example. You can see that the kangaroo jump from 0 to 3. You can see from 0 to 3. Then the second kangaroo now jump from 4, like it jump, the distance of the jump now, the distance of this first kangaroo jump is 3. It's jumping like 3 steps, 3-step jump. Then the second kangaroo at index 4, let me just put it that way, or the second kangaroo here at index 4, what does it do? It jumps by 2 steps, right? It jumps by 2 steps. So that's what you can see in this diagram. You can see that kangaroo 1 jump from 0 to 3. Then the second kangaroo jump from 4, see it here, 4 to 2. From 4 to 2. So they continue jumping. And now when they jump up to index 12, like index 12 of this table, as you can see, they are both at the same location. So it means return yes. So let's just go straight into the algorithm and see how we can solve it on our own. So like I said, the idea behind this algorithm is to like, just as we have seen there, when 0, 3, just as you can see 0, 3 here, where is it? Let me just show you what it is. 0, 3, as you can see here, is 0, you jump from 0 to 3. This one jump from index 4 to so what you just need to do is that you'll be adding the jump, like the interval, like the what is it called, the distance, the jump distance. Yes, the jump distance. You just be adding it, continue adding, like this one that is 2, for instance, this one that is 2, this one that is 2, for instance, it will be jumping, that will be adding 2. 4 plus 2, 6, plus 2, 8, you can see, plus 2, 8, plus 2, 10. The one for 3, 3 plus 3, 6, you can see. So that is how to solve this algorithm. So let's just go straight into it right away. So the first thing to do, we say okay, and here we have I think we have some constraints to work with, like, okay, good, x1 and x2, they are both less than 10,000. v1 and v2 are both less than 10,000 or equal to 10,000. So let's just do that right away. So in my own logic, the way I'm looking at it is to add it, like continue adding. Where anywhere they are equal, I return yes. If they are not equal, then I return no. So just follow me as I solve it, so that I will not take too much time to get it done. So first thing, what will I do? I will use loop because since it's less than or equal to 10,000, this is what I will do. I will say for let I equal to 0, starting from 0, then I is less than or equal to 10,000, then I plus plus, because we are incrementing, we are going forward, we are not moving backward or subtracting. So now I will say that since I want to be adding, and there's a logic that we can use here, we can say let's kangaroo 1, I can say kangaroo 1 equal to this x1, which is the starting location, plus this index, multiply, we now multiply it by v1. So why we are multiplying is that because the loop will continue going. So what we want to do is that we want to use the index. We are multiplying the index with the distance, because that's only what we can do. You multiply the index with distance, so that the index will be increasing and also be multiplying, giving you value that is equal to kangaroo 1 distance that is covered. So then I will say kangaroo 2, I'll just copy this. Let me just copy this. Okay, see. I can do cons. I can do cons. Since I'm not reassigning, so I can use cons equal to, no, this one will be kangaroo 2. Kangaroo 2 equal to x2 plus I index multiplied by v2. So the same thing applies to both of them. So we multiply the index by the distance and add it to the starting position. The starting position is constant, but the index that we are multiplying with the jump distance will be changing. So now say if anywhere they meet, so if, okay, I'll just clean this. So if kangaroo 1 is strictly equal to Kangaroo 2. It's strictly equal to Kangaroo 2. So we return yes. So we return yes. But our function should return no. If not, if that is not the case, return no. Let's run this code and see if it's working. Okay, good, it's working. So it's passing the test case. Let's run the major code to see if we pass all the test cases. And here we go, we pass all the test cases. That's really nice. So as a recap, what we did here is to like use the appropriate logic. This is efficient, though we are looping though, but it's efficient. We can also use map that has index, the value and the index. We can use it to also solve this algorithm. So that is it. If you have any questions, you can drop in the comment section. I will look at it. Thank you.